Welcome to NaxToView. The following video explains how to create derived results thanks to NaxToView. To create derived results, you have to click on the icon shown on the screen. A new window will automatically open. Derived results can be from load cases or components. In other words, this module allows you to combine load cases or components within a result. Let us first explain the results derived from load cases. They can be based on a function or an envelope. Load cases derived based on a function are explained below. This tool is used to create a new combined load case, in other words, a load case that is a function of other original load cases that already exist in the file. To create a new load case, the first thing to do is to give it a name. We will call it new_load case. In this example we are going to make a linear combination of two. So, the new load case will be the result of load case subcase 2 plus load case subcase 4. In the table shown on the screen, what is done is to select the load cases that we want to combine. To add them we click on the orange plus icon. In the lower table is where a regular expression of how they will be combined is shown. In this case, it is the sum of the two load cases, but you could do a subtraction, a multiplication of one by the other, you could put the difference and then multiply it by 3. Or whatever you want. The question is to define the expression. To find out if the expression is well defined, you can consult the help by clicking on the eye icon, where the user's manual will open directly in the derived results section. Once the expression has been defined, simply click on the green plus icon at the top right. As shown on the screen, this load case becomes one of the load cases available to the user to plot the results. Derived load cases are always negative integers numbers, that is what differentiates them from an original load case. Next, we are going to do an example of load cases derived from an envelope. In this case, what it does is to obtain from a list of load cases the maximum extreme, the maximum extreme or the range, which is the difference between the maximum and the minimum. As in the previous case, you must give it a name, in this case envelope_maximum, and choose the load cases you want to form it. You can take all of them or select only some of them. Once chosen, it is indicated that the criterion will take the maximum value found in the contour. What it will do is to process each of the load cases, obtain the contour that we get for each of the load cases, and then, among all these, it will apply to the element, in this case, the maximum of the values that there are for that load case. Once you have selected the criteria to create this derived load case, in this case based on an envelope, click on the plus button and, as in the previous example, it appears in the list of available load cases with a negative number that are usually consecutive. If we had set the min, it would be the min. If we set the extreme min, it would be the minimum among the absolute values. The same happens for the extreme max and range. By default, it is set to by contour. This option will get the contour, that is, if you plot displacements or stresses it will get the maximum stress in that element, in the selected component and for that list of load cases. But you can tell it not to get the contour, that is, not to get what is properly the result, but to select the option by load case, and in this case, what you get in that value that will be assigned to the element is the ID of the load case that produces the maximum stress or displacement. And the same for by increment ID if the model has several increments. In this case this model has only one increment in each load case, but if it has several increments, what is plotted, that is, the value that is assigned to the element is the ID of the increment, which produces the contour max, min, etc., in that element. In addition, there is another option which is to consider all increments. This is useful if what you want is that the envelope does not consider for each load case a single increment but considers all the increments that are in that load case. To do this, click on the All Increments option. When selecting the new load case, we choose what we want to see of the envelope, type of result, component of that result. In this case we have chosen the maximum value criterion, and, for example, we can choose to plot the stresses, in the von Mises component and the sections none. Plotting on the screen shows for each of the displayed elements the highest value of von Mises stress occurring among all load cases that had been selected. If you show the results in the output tool you will see that each element has a value, for example 128.3282, which are the voltage values that occur in that element in some load case of all that had been selected, and that corresponds to the highest value. If you put the option by load case instead of giving you 128.3282, it gives you one of the IDs of the load cases of the table, indicating in which load case the maximum contour occurs, or the criterion that we have chosen. For example, if we recreate that same envelope and tell it to do it in by load case, we call it envelope_ID load case. And in this case, it doesn't give you the envelope, it gives you a load case ID. We create it, update the output table, and see how the load case ID comes out. That tells you is that in that element the load case that produces the highest von Mises voltage is the 54,611,647. That's the difference between the three buttons below, which is what you want them to plot. Normally you usually want the contour, but if at some point you want to locate what is the load case that produces that maximum on that element, you do an envelope where I ask it to show me on the element the ID of the load case that produces that maximum, minimum or whatever. With this we finish the explanation of the part of results derived from load cases. The next option is results derived from components. With this option NaxToView allows is to create derived components. This means that within a result in which you have a series of default components that appear in the table and that are within the model, you can combine them and get a new component. For example, in stress you invent one. In this case we call it magnitude_forces. That is going to be the stress in Fx squared plus the phi squared, and from all this the square root is calculated. Now the magnitude_forces is created inside forces, which is the result type. When going to any load case, including derived load cases, the new component that has been created will appear inside forces, magnitude_forces. And when plotting the results, the squared component will appear. The derived results, regardless of whether they are load cases or components, can be edited and deleted. To edit them, simply select the derived result you want to edit from the list and make the desired change. Once the change has been made, click on the floppy disk icon to save it. This is the end of the explanation of how to generalize derived results using NaxToView. We hope it was helpful and see you in the next video.